Hi students, we meet again. Today we're going to continue our basic mathematics chapter 3 function and graph part 2/2. You're going to do the same thing at the beginning, that is to pause this YouTube and then prepare 6 pieces of A4 paper. What should you draw and write inside the A4 paper? Like last week, you're going to have 3 boxes and then you have the so-called horizontal box there with tutorial 6.1 and your student ID. Tutorial 6.2 your student ID, tutorial 6.3 your student ID until the last tutorial 6.6. Okay, take some time, maybe 5 minutes to prepare this paper. It's going to be very useful from now until end of our slides. After you have this 6 paper prepared, what you are expecting to accomplish is by this Wednesday here, you're going to copy and then you're going to solve the question at box 1 and box 2, box 1 and box 2, box 1 and box 2 until the remaining tutorials, and you're going to submit before the due date at this particular website here. Last week, we go through function and graph for 3.1 until 3.3, the basic concepts, graph of functions, and then operations of the functions. For this week, we're going to be more focused on type of function, that is quadratic functions, polynomial functions, and then the rational functions. We're going to know how to draw the quadratic functions, polynomial functions, and the rational functions. And then there are 4 important dates as listed right hand side here. So today you're going to spend roughly 30 minutes to go through the video and then do 6 exercises. And then by tomorrow 5 p.m. you're going to complete the exercise at box 1 and then you're going to DIY your own question at box 2. You're going to submit box 1 and box 2. By this Thursday, you are given another 12 hours to go through 1 YouTube video and then you're going to solve questions at box 3. What is your submission time? That is before 8 o'clock this Thursday. Go to the first section, that is quadratic functions. Before we go into quadratic functions, let's recall back what is function. Remember last week we have this similar graph with the functions stated as 2x power 3 plus x squared minus 7. This is a function. Why we say this is a function? Because there is a relationship of one input and producing only one output. One input, one output. That is, when we have one input here, the x, we're going to see that, oh, there's only one output here, right? How about when we go further right, we're going to see that one input, we're going to produce only one output. That is a function. A function, when we put into the graph perspective, we're going to see that there's only one output line there, like this graph. Next, we're going to define a quadratic function. In a simple way, it is a polynomial function of degree 2. How can we write it? There are 2 ways. The first way is the general form, like what we exposed to the quadratic equation, quadratic functions. Here, there is a higher level of degree 2, and then we continue with 1 degree and 1 constant coefficient. There's another way to write it. We call it the vertex form. This is the way. The function is written in a vertex form. We're going to rephrase it, and then we're going to have a new value h and k. Is it h and k very important? Yes. When we put into the graph, when we have the vertex form, you'll find that it's very useful. The h and k will become the vertex point. For this problem, it is a minimum point. Sometimes we're going to have a set face that is producing a maximum point. How can we get the value of h and k from general form? This is the formula. H is defined as negative b. Where can we get the b? It's from here, b. Divide by 2a. Where can we get the a? A is from here, the first term. Then we have the h. How about k? K is defined as the value of the function when the input is h. So the function, initially we have x to represent it. Now to find k, we replace it with the value h. It means that to find k, we need to know h first. Is the general form useful in drawing the graph? Yes, it's producing one important information, that is the c here. You see, when we have the value c, it is the constant coefficient. At least we can plot the graph through the y-axis at value of c here. This is the usefulness of the general form. It depends on the situation. If we are more concerned about looking for a maximum or minimum point, we can rephrase our quadratic function into the vertex form. Or else, in the normal condition, we just write it in the general form. We're going to look at one of the exercise here. Will fall inside the tutorial 6.1. Remember to write your student ID. And you can start the tutorial 6.1 by draw the graph and also write the formulation there. The question is, you want to express the function, the quadratic function equals to 5x squared minus 30x plus 49 in the vertex form. Remember, vertex form, not the general form. And then you want to find the vertex point and sketch the graph. Let's go to the formula. The formula on finding h equals to negative b divided by 2a. b is negative 30 divided by a is 5. So we're going to get the value 3 for h. h is 3. Now we want to find k. K is easy after we get the value of h. It's equals to functions when the input is h. For our case, f3. Let's expand it. Normally we have the input is x. Now the input is 3. And after the expansion and the simplification, we have k equals to what number? 4. So vertex point is 3 and 4. When we go to the first term here, we found that the value is positive. So we're expecting there will be a so-called minimum point, or we call it the smiling face. And then the vertex point is 3, 4. This will be our curve, the quadratic function for fx. Okay, this is the graph that we sketch. Now, it's your turn to create a similar question and then solve it. You create a similar question here and then you solve it. The box 3, you leave it blank first. Leave it blank first. Okay. Now we come to tutorial 6.2. This is an application questions. You want to know what is the new ticket price. Okay, the question start with a stadium. It has 1,200 seats, and then the owner charged 5 ringgit for each people. And the good news is it is always occupied, the stadium. Let's say there's a football match, always 1,200 people because the ticket fee is cheap, 5 ringgit. But now the owner, he wants to increase the ticket fee, but he found that each 50-cent increment will cost less 100 people attending it. Now you want to calculate the new ticket fee with the condition it will maximize the ticket sales, because at the end people want to earn more money. So earning more money is to get a better sales. Let's see whether we can solve this problem. There is two situations. The first one, the old sales. The old sales is direct. Sales equals to, as mentioned here, the formula, ticket fee times the seat. So for this case is 5 ringgit times 1,200. So it producing 6,000. So the old sales is 6,000 ringgit. How about the new sales? Before we build the relationship, we want to define one variable. It's called x. X is something that we don't know. It will be changed. It is how many times increase. The owner don't know he want to increase one time 50 cent or he want to increase 4 times 2 ringgit. But at the end, the condition is he wants the maximum profit. Okay, the new sales, the new one, equals to the new ticket fee times the new seat there. We don't know the sales, the new sales, but we know that his intention is to increase 50 cent. How many times? X times, right? X here. But when he increased one time, there will be 100 people less attend it. Now we have two expressions there. 5 plus 0.5x. 1,200 minus 100x. When we expand it, we're going to get a quadratic expression here. 6,000 plus 100x minus 50x squared. You want to find the maximum ticket sales. Means that you want to find the vertex point. How? Let's go to the blank area here. We want to find the h. Equals to minus b divided by 2a. What is b? b is 100. Minus 100 divided by 2a. a is negative 50. 2 times negative 50. So we have h equals to 1. How can we find the value of k? K is defined as the function when the input equals to what? H. Or for this case, h equals to 1. Let's expand it and see what's the value. The function equals to 6,000 plus 100 times 1 minus 50 times 1 squared. What we're going to get? 6,000 plus 100, we're going to get 6050. This is the K. So when we plug into the graph here, okay, sorry for the too occupied with so many things here. So we found that the maximum point equals to 6,050 ringgit when there is one increment here, 6050. Means that the owner are suggested to increase one time only. When he increased one time, he increased how much? 50 cents, right? Then from the old price is 5 ringgit. So he increased one time is 50 cents. So now the new ticket price, ticket new, would be RM 5 ringgit 50 cents. This is the answer. Now what you need to do is you want to design a similar question and solve it. At the same time, leave the box blank, okay? Let's go to the next section, 3.5 polynomial functions. We have a polynomial functions and the opposite of it. We call it monomial functions. Monomial function is a function when we only have one term there. Equals to 13, equals to 3x, equals to negative 57, or equals to this term here, 520x squared y squared. The polynomial function is when the function comes with more terms. Let's say this one, or that one, or the last one here. A poly implies many. This is why it calls polynomial function. When we have one polynomial functions, it can be expressed in this general form here. Px equals to a n, the n term, x with the n term degree, plus a n minus 1, x n minus 1, until the last one, a with the 0 term here. For each term here, or expression, we have a name for it. The first one, see, this is the first one. The name, we call it the leading term. When we just concerned about the a n term here, it is the leading coefficient. How about this one? With a with n term, a with the n minus 1 term, a the second term, a the first term, and a the 0 term. We call it as coefficients of this polynomial. And the last one is a with the 0 term. It is called the constant coefficient. It is at the end a value, a number. Let's see one example. Okay, for this case, we have the leading coefficient is 3. Yeah, leading coefficient. Yeah, there. Okay, leading coefficient. And then we have the leading term 3x5. It's called the leading term with the degree of 5. Normally we call it power of 5. And then the last one is the constant coefficient here. Yes, it's a number only. It's minus 6. Minus 6. And more things appear. It's called the coefficient of the polynomial. Coefficient is a number. It's not x, it's not y, it's a number. So we have coefficient of the polynomial start from the first term here, the 3, the 6, minus 2, 1, 7, and minus 6. Yeah. Okay, for this section, we want to do two things. The first one, we want to dividing the polynomials. And the second is we want to sketch the graph of the polynomials function here. Before we dividing the polynomial, it's good to know the general name for each section there. Okay, we're starting with the given case here. So we have 38 and 7. What we call 38 is a dividend. And how about the 7? We call it the divisor here. When we express it in the another way here, so we have the value 5 is called the quotient, and then 7, same as the left hand side there, we call it the divisor, and then 3 is the remainder. This is one example dividing a number. When we are dividing the polynomials, we have the first polynomial px, we have the second polynomial dx. It's easy to remember. P is the long polynomial functions, right? And d, why we use d is for us to easy to recall, is a divisor. And the q is the product of the dividing process and process. So q is the quotient, and then r is what? The remainder, and d is the divisor here. So when we divide these two polynomials, it producing this way to express it, or else we can rewrite it in another way. Both acceptable. It depends on the question. Ask us to express it in the first way or express it in the second way. Let's look at the question. Tutorial 6.3. So we are given two polynomials. The first one is the px, and the second one is the dx. So now we want to find the polynomial qx is the quotient, the first term at the right hand side there, and then the rx. R is representing the remainder, so that px equals to dx times qx plus rx. Okay, we are given two polynomials, right? This is the first one, the px, and this is the second one. What's this? A dx. We are asked to divide those two. Okay, the first step is to solve for the higher degree, that is power of 4 there. So after the expansion, after the minusing, so we get the next level here. So we want to solve for the next level. So we have the balance here, the remainder, negative 7x plus 1. We cannot further divide these two because our divisor comes with the higher degree. We cannot solve for this one. So now we have the divisor, the dx, we have the quotient qx, and then we have the remainder rx there. Now we want to rewrite it in this form. We just plug dx, okay, where's dx? Here, into the first expression there, and then qx, where's qx? Qx is here. Okay, and then we have the remainder. Solve. Now it's your turn. DIY a similar question and solve it. Leave the third box blank. Just now we learned about how to dividing two polynomials. Now we want to expose ourselves how to sketch, not draw, not put it in a very precise way. We want to sketch it. There are three aspects that can determine the sketching process here. The first one, the easiest one, is we defining the y-axis value. That's using the constant coefficient. The constant coefficient, remember, is a0, the last term. The last term. Only a value, a number. At least we can pinpoint where will this graph go through. The second is we want to check the leading term degree. The leading term is the first term, an. Okay. What is the useful of the the leading term degree here. The degree is this one, the power. When we know that, let's say the power is 5, we're expecting there is up to 5 minus 1. There will be up to 4 vertex points only. 4 vertex points. Up to. It may comes with 1 vertex point, but maximum 4 vertex point. So the third aspect is a more complex thing. We want to find the leading term degree. Is it odd or even? Okay. Odd means that power of what? Power of 3, power of 5, power of 7, power of 9, etc. When it is even degree, there's power of 2, power of 4, power of 6, power of 8, 10, etc. And the leading coefficient is either positive or negative. Okay, leading coefficient is which one? Is the A. Is the A the number? Then we can determine the end behavior of this function. What is the meaning of end behavior? It is the very far to the left and far to the right hand side. What are you going to see here? Okay, when we have an odd degree, odd degree here, plus when we have the leading coefficient is positive, we're going to see that when y goes to negative infinity, the x will go to negative infinity. When y goes to positive infinity, the x goes to positive infinity. Then the second case, when we have our leading term is even. Let's check at the case here. The leading coefficient is negative. The leading coefficient is negative. The leading coefficient, this one, is negative. So we're expecting to see this kind of curving here. That's to say that when our y goes to, when our x goes to very far negative infinity, our y will go to infinity to negative. Then when our x goes to positive infinity, go very far away, we're expecting our y will become a negative value there. Okay, it's a bit confusing, right? It's okay. Let's go to the question. We just want to sketch. We don't want to draw it precisely. Okay, we just want to sketch it. Okay, tutorial 6.4. Okay, want to sketch the graph here. Okay, the first one, we determine the constant coefficient. We have negative 7 here. And then the leading term, we are guessing there will be up to 3 vertex points there. And then let us check the leading term degree. Is it odd or even? This, for this case, is even. And then the leading coefficient, is it positive or negative? Is a negative. Okay, when we check the graph there, this is the even. Okay, and then it is a negative, so we are choosing the case here. So we're expecting we're going to form some kind of this curve there. Okay, negative 7 here. Okay, they are up to 3 vertex point. 1, 2. Okay, at least we have 2. We are not go up to 3. It's acceptable. Then the curve will be something like this. Done. Sketch only. Okay, this is how we sketch it in details. Okay, now you try to sketch this graph yourself. Oh, I'm sorry, it's the same thing. Okay, it's 6.4. Just now you did it right. This kind of the sketching here. DIY similar question and then you solve it. But next we go to 3.6 rational function. When we have a function defined as gx divided by hx, another function divided by another function, and we know that this is a rational function fx. How can we sketch it? We can sketch it by defining three particulars here. The first one is the vertical asymptotes. We can write it as vertical asymptotes. It happens when the hx cannot equals to 0. In order to find it, we just make it hx equals to 0. Then, to find the horizontal asymptote, before go that, the vertical asymptote. This is the vertical asymptote. The line that the curve not there to touch it. Not there to touch it. Okay. The second one, horizontal asymptotes, is defined as the vertical lines that the curve dare not to touch it. Dare not. How can we find the horizontal asymptotes? It's more complicated because it depends on case. Let's say for case 1, when our degree m is smaller than the degree n here. So the horizontal asymptote line is y equals to 0. Okay, y equals to 0 is this line. I use the blue color. Okay, this line, y equals to 0. Okay. Let's say case number 2, when m equals to n. Let's say m is power of 3 and then n is power of 3 too. So the horizontal asymptote line is y equals to a divided by b. So a divided by b here. The case number 3, for m equals to n plus 1. M, let's say, is 3, n is 4. So it fulfills the case 3. So the asymptote line is y equals to mx plus c. Where's m? M is the value here. For this case is 3. X, we don't know. How about c? C is the value c here. Case 4, when m, the degree, is greater than n plus 1 is greater than n plus 1. So there is no horizontal asymptote. There's no. Then next, we want to find the intercepts. The intercepts defined as the point when fx equals to 0. When fx equals to 0, where is the point intercepts? Somewhere here. Then we want to find when x equals to 0, where is the y-intercepts? So it easily can be found when we have the intercepts points happening at y-axis and x-axis here. And then we're going to plot the points very close to the so-called the vertical asymptotes, the horizontal asymptotes, and also the intercepts. After we have 1, 2, 3, 4, then we can sketch the graph. We can somehow sketch the graph there. Okay, let's go to 1. Okay, there's already the answer here. It's okay. Okay, we want to sketch fx equals to 1 minus x divided by x plus 2. Okay, let's go on finding the vertical asymptotes. Vertical asymptote is the vertical line from up to down. Want to find from up to down. Later down the horizontal and the intercepts. Okay, then we want to plotting the points and then we're going to sketch the graph later on. We see how to sketch the graph. Okay, the first one, vertical asymptotes. When hx equals to 0, where's hx? This one. X minus 2, x plus 2 equals to 0. So x is minus 2. This is the vertical asymptote. X is here, minus 2. So we have the vertical asymptote. We want to find the horizontal asymptote. It depends on case. Let's check in the case. What's the highest degree here? 1. What's her degree for hx? Is 1. Okay. it falls under case 2. So the line, the so-called horizontal asymptote, will be the y equals to a divided by b. A is -1, b is 1, so equals to -1. Okay, here. Sorry for the delay. I'm looking for a -1. Okay, -1. We have it here. So we want to find the intercepts. Intercept when fx equals to 0. When fx equals to 0, 0 equals to 1 minus x divided by x plus 2. So x equals to, here, x equals to 1. Okay, intercept point here. And then for the case when fx, what is fx when x equals to 0? Okay, we write it here. When x equals to 0 equals to 1 minus 0 divided by 0 plus 2, which equals to 1 over 2 here. So at least we know that there is one curve going to pass through here. We use the blue color. Okay, pass through here. And then normally for the asymptote case, we will have the opposite value, opposite curve there. Okay, we'll draw it here. So we already sketched the graph. What's the plotting points for this case? In case we're interested, we can put it into the table. Okay, x, we can have the value of 0, 0.5, 1, 1.5, and we look for the corresponding, what is the value of the y, of the fx here. It helps us to make more points. Okay, more points. But for this case, we have the intercept points is sufficient already for us to draw the rational graph here, rational function graph. Okay, same, do a similar question and then solve it. 3 blank. The next one, tutorial 6.6. This one is a bit difficult because we having the quadratic expression for the birth function and the denominator function there. For this case, you try yourself. Can you find the vertical asymptotes? Vertical asymptotes is when x squared minus 4 equals to 0. What is the x? So for this case, x happen to be 2 points when x equals to 2 and minus 2. The horizontal asymptotes, it depends on what is the degree for the numerator and denominator. We still fall under case number 2 because both have the degree of 2. Since that, our horizontal asymptote will equals to a divided by b. A is how much? 2 and 1 equals to 2. So our horizontal asymptote is equals to 2. So next, you want to find the intercepts. When the whole function equals to 0, what is the x? When x equals to 0, what is the function value? Next, you're plotting the points. You can create the table and then just put some of the importance number there for x, and then what is the correspondent y there. Okay, and then you're going to sketch the graph. This will be your graph, a bit small, but you're going to have how many curves there? 1, 2, 3 curves. Same, do a similar question, but this time is more difficult one relative to 6.5, and then leave the third box blank. Okay, today is Tuesday. By tomorrow 5 p.m. Wednesday, you already completed box 1, box 2 for tutorial 6.1. Same goes to tutorial 6.2. Same goes to tutorial 6.3. You already completed with all your answers and solutions. Okay. And then go to submit where? This website, tinyurl.com/mathematics0605.